Hi everyone, welcome back to Comp 3430 Operating Systems. I want to, what I'd like to do is just kind of give you a quick week summary. So we're moving fast, and I think it might be worthwhile to just take a minute, take a look at the learning outcomes, and get a sense of where we're at and what you should be able to do based on where we're at in the course. So here's the ROAS for week one. Lab one is due today. It's due at 4:30. The learning outcomes that we have for this week are kind of all over the place, and they're kind of all over the place because of like we're hitting the ground running here. We need to get started, and we are getting started pretty fast. So I want to take the time to just step through them sequentially and get an idea of what you should be able to do and where you can find that information if you don't feel like you were able to find that, especially when it comes to getting ready and preparing for term tests and final exams. So for the first set of learning outcomes related to processes this week, you should be able to write code that uses system calls to create and manage a process. So that's system calls like fork, exec, and wait. This is also described in chapter 5 of the textbook. We did this in class, and we did it a little bit more like here's how you use these APIs. They also do it that way in the textbook, but it was worth taking a look at in the classroom. Describe the life cycle of a process. So this is in chapters 4 and 5 of the textbook. And you kind of get a sense of what this looks like based on the way that we were interacting with the system. So starting processes on the command line, talking about how the shell is working. So it's launching a process. You type something in, you press enter. It does fork, exec, and wait itself. This is also related to, in the textbook in chapter 4, the idea of a process having a state. So a process being able to run, a process running, and a process that has just ended. The life cycle of a process is kind of like it starts, it runs, it's able to run, it gets into blocking states eventually, and we were taking a look at that in terms of synchronization later on. But kind of like the start, run, end life cycle. You should be able to describe and distinguish context switching and mode switching. So this is a learning outcome that's related to Comp 2280 when you're talking about that system and user modes. Mode switching and context switching, these are described in chapter 6 and in the video that goes along with chapter 6. Again, the videos and the chapters, in these cases, it's kind of like pick one or the other. The context switching and mode switching. Context switching here is the operating system and the hardware taking stuff off of registers, so like the current state of a process, and then persisting it somewhere, saving it somewhere, so that when you switch between processes, you can restore the context. You can restore the state of a process. So whatever the instruction pointer is, whatever the stack pointer was for that process, you can restore that. Determine what an OS might need to know about a process. This is what we did in class yesterday. This was the exercise where we're basically going through a piece of code and trying to decide, like, for each line of this code, what does our operating system have to be able to support? Describe how an operating system manages processes, so data structures, control of processor and modes. Control of processor and modes is related to context switching and mode switching in chapter 6. And then this idea of hardware interrupts. So the operating system can regain control of the processor after a process has started to run on it. The data structures here are things like the process control block and things like the open file table. And again, that's kind of what we were discussing yesterday. In terms of how you're going to be assessed on these outcomes, write code that uses system calls to create and manage a process. This is something that you're being assessed on in the lab and in the assignment. Describe the life cycle of a process. This is something that you may be assessed on something like a term test or a final exam. Describe and distinguish context switching and mode switching. Same thing. So kind of on a test or a final exam. determine what an OS might need to know about a process, and describe how an operating system manages processes. To me, these things are very related to each other, and you would be assessed on that in something like a test or on a final exam. For part 2 of this week, and again, we're kind of like in the state of there's stuff from part 1 and part 2 all mixed together this week, and then going forward, we're going to be a little bit more structured about it. The learning outcomes here related to inter-process communication were write code where processes communicate through message passing via signals, pipes, and FIFOs. So we've done signals and pipes in class. This is also in the Advanced Programming in the Unix Environment textbook, and this is also in the video that's attached to that chapter. The video that's attached to this chapter goes into a little bit more detail about signals. So if you're trying to make a decision about which one of these you should be reading going forward and for review and stuff, I would defer to the video as opposed to the textbook here. The write code where processes communicate through message passing via signals, pipes, and FIFOs. Pipes and FIFOs. Pipes, you're being assessed on this in the lab this week. Pipes and FIFOs, you're being assessed on this in the assignment that's due next week. For signals, we don't actually have an assessment in terms of writing code for lab or an assignment. So this is something that you may expect to see on a test. Describe how the operating system supports and implements shared memory, signals, pipes, and FIFO. FIFOs, we're going to see FIFOs very first thing next week. In terms of how it implements and supports signals, pipes, pipes, and FIFOs they're kind of the same idea. We'll see this. There's one main difference, and that's that there's a file that backs the pipe for a FIFO. But signals, so we saw this idea of a signal handling table, so that every process has a set of handlers that it's registered for signals. This is kind of how the operating system supports that. Pipes, we have this idea of the open file table, and then there's queues that are sitting behind that, and the queues are being not duplicated when the fork is happening. And each of the read and write ends are operating on a queue. So the kinds of things I'm looking for here are like the data structures that are being used to implement pipes. This is something, a describe learning outcome. This is something that you're going to be assessed on in a test or a final exam. The last learning outcome here, compare and contrast the shared memory and message passing programming models and their relationship as seen through the lens of synchronization. So we saw this a bunch of times. The synchronization idea, the keyword that I kept using was this word blocked. And blocked was the idea that when a process is running and it runs certain system calls, it's going to have to stop and wait for things to happen. One of those system calls was literally the wait system call, where we're waiting for a child process to finish. But this is also things like read. I'm going to call read on a pipe or on a file descriptor, and I cannot proceed until there's actually something there for me to read. So until somebody else has written to that pipe. We also then saw this in the form of signals, where this is kind of like we can use signals to enable synchronization. So we can send a signal to a process, and then it will change a flag. It will change the state of something so that it's allowed to proceed. But this is a significantly more primitive approach than just using something like pipes. So write to a pipe to indicate that it's ready to go. So compare and contrast, again, this isn't something that you're doing very much in an assignment or a lab, but this is something that you should expect to see on a term test or a final exam. All right, so I hope that was helpful. If that's helpful, please let me know. I think I'm gonna try and do this every week, just so that so that we're on the same page about what's being expected of you in terms of assessment and kind of where we should be at for each week going forward. That's it. Thank you for watching, and again, I hope you have a great weekend, and I'll see you on Monday. Bye.